Can anyone help with minutes? I'm going to be taking notes myself, but it'll be best if we have a backup to take whatever notes I could miss.
Hi, Juan. I could help, but I also have a presentation. That's why.
Okay, perfect. Thank you very much, Chopin.
Okay, cool. You're welcome.
And, thank you. And well, it's the hour now, so I guess we can get started. Hi, Wasim. Welcome. Great. So, welcome everyone to IETF 110 Intarea Working Group. My name is Juan Carlos Zúñiga and Wasim Haddad. Second, let me play here with the screens. So, the virtual meeting tips and etiquette. Please join the queue. Raise your hand before participating so that we can handle the queue, and make sure that your mic is muted unless you are speaking. Ideally, we want to turn off video to save bandwidth. And below you have the details about the meetings and Meetico. For the note, well, this is an official meeting. You're probably familiar by now, but by participating in this meeting, you agree to follow the IETF process and policies. So please, if you're aware of any contribution that it's covered or related to a patent or patent application, please disclose it either to the list or to the chairs. Also, for your information, this meeting will be recorded, and your attendance will be registered. So minutes are being taken. Your presence again is logged. For the scribes, I actually have the wrong links there, but it'll be best if we can contribute the online minutes to the Cody MD directly. As a reminder, these minutes are going to be public and may be subject to discovery in the event of any litigation. So blue sheets are automatic from your attendance. Note taker, we have a note taker. Can we have someone to help with Jabber?
On the other hand, right, to be honest, it's Eric here. There is no real need anymore to use Jabber, so no need for a Jabber scribe.
Okay, perfect. Thanks, Eric. So moving on to the agenda bashing. So we are going to start with the usual document status updates from us. I'm then going to move on to give you an update about the Martinez BOF that took place at the last IETF and the side meeting that took place yesterday about MAC address randomization. Then we have Tommy talking about per-application networking, Pascal on SHIC or PPP, Shuping on APN, and then we have Ihao on challenging scenarios and problems in internet addressing. Any questions or points about the agenda? Okay, so hearing none. For the quick update, so a reminder, we had the provisioning domain names and data published as RFC 8801. We also had the IP fragmentation considered fragile, published as RFC 8900. And the GUI, which is version 9, it's on ID evaluation, so still going through the process of publication. The other news that we have is on the SOX protocol version 6 from Vlad. So that draft was moved to the independent stream. Moving on, just a quick update on the Martinez status. Martinez is a BOF that took place at IETF 109 to look at MAC address randomization, especially around Wi-Fi, and the effects on networking protocols and infrastructure. So basically, is how to address the fact that new standards and operating systems are now randomizing MAC address, and this is because of privacy issues that were held before regarding the long-lasting identifiers embedded in, especially in IEEE 802 protocols, notably the MAC address that could be used to track individuals unwillingly. And then there have been new changes to standards and operating systems where this address is changed. Now, because this address was used as an identifier by upper layer protocols, we are looking at what could be the potential disruptions on these protocols, and if there are existing solutions, if these solutions should be recommended, or if actually we need to work on some new solutions. Of course, this in the scope of IETF, meaning protocols like DHCP and so on. So there's a couple of drafts. One was discussed heavily yesterday on the problem statement, draft Henry Medines. Then there's also the MAC address randomization background by myself and a couple of co-authors, Amelia and Carlos, that try to explain what is the background of this effort. And in the upcoming meetings, we are expecting to have first an interim meeting in mid-April, and then we are foreseeing probably having another BOF at IETF 111. So if you are interested in this topic, we encourage you to join the mailing list, and you have the link there. Okay, so that's it for updates. Next, we have Tommy. Would you like to share your screen?
Do you have the slides on your side?
Yes, give me 1 second.
If you don't mind.
One second. I'm having an issue here with permission, so let me try again. Probably because I stopped. It's not letting me share again. I don't know if it's because I stopped, so give me 1 more sec. Okay. Does it work?
Yes, you can see it now. Thank you. Thank you for sharing those. All right. So I'm going to be sharing a update on a draft that we actually wrote last November. We didn't have time to talk about it then. We haven't done an update because I think it's the content we believed was still relevant, but we'd like to have a discussion here and get people's input and see if it's something that we believe that this group should work on. And so this is a draft about per-app networking considerations. And I have co-authored this with Lorenzo from Google. I'm from the Apple side. And next slide, please. So the motivation behind this is we've seen a lot of conversations in IETF, in proposals, as well as conversations outside of IETF in 3GPP and other venues that are talking a lot about having application-based networking, application-aware networking, having a tighter integration between the network and applications. And this has a big impact on the architecture. It has a big impact on how we think of data going through the internet layer. And what we felt was missing was a IETF kind of statement and position around the problem space, the right way to approach it when you're talking about putting this type of information in IP or near it. And so this draft is more of a requirements problem space description draft. Is meant purely to be informational, to help kind of set the stage and define the principles that we as a community would believe are the right ones to approach this problem. And so we tried to write down what we thought were the principles that we were coming from as client OS implementers, but we'd be very happy to have that scope and authorship be broadened. Next slide, please. So I'm just going to walk through essentially the different sections of the draft and what we're saying in it, if you haven't read it. So generally, first we start out with the use cases, and there are many legitimate use cases in which there is a desire to have more deep integration between an application and a network. And you particularly see this when you have mobile devices that are connected to different networks or have different capabilities for access. Some of the use cases are, you can have a very dedicated network access that's only meant for specific things. This is very, very common in the cellular world, in which I have a specific APN that's only usable for a specific application that's doing messaging, voice calls, something like that. But you also see this when you're on a walled garden network. And you can only access the media on the airplane through this particular link. And you want to be able to have a strong binding between your media player and that particular access. And this is very much related to the work that we already did in Intarea around provisioning domains. You can also have enterprise networks that have different types of routing. You have cases where maybe you have voice or video calls wanting to have a special channel, so they are treated differently than generic download traffic. Services often are 0 rated on specific networks, and that requires some type of identification. And then you can also have cases of local breakout where you need to route traffic differently just to get to local resources. Next slide. So those were that's the positive side of what are people trying to achieve, but there are a lot of concerns about how we approach this problem and how we achieve that. And today, generally, we've kind of just fallen into mechanisms that were convenient because there was a lot of information that was sent purely unencrypted, available to anyone. So you could do a lot of interception or deep packet inspection. So this can happen by intercepting DNS. This can happen by looking at flows and examining the TLS server name indicator on flows. And generally, while we recognize that this is something that has evolved organically, there are a lot of problems with deep packet inspection as your main mechanism for routing traffic. It's complex. There are a lot of policy and privacy concerns. And as we see more and more encryption, which is very much a good thing, this is becoming more problematic and less effective. And I think we can argue that that's what is causing a lot of the new proposals of how do we put more and more information that is less protected. And this has led to a lot of these new proposals that we are listing here. And so we're trying to, in this draft, explore the implications and suggest ways of mitigating the problem. Next slide, please. So, some of the problems, of course, are around open internet or net neutrality, how traffic is being treated. If this is being done without any consent of the user of the application, that can lead to a lot of problems. And there are essentially, two general types of mitigations you could have to this. You could more generalize the markings you have for your traffic to say that we need to focus on traffic classes and traffic categories more than specific application identifiers. And the other alternative is to put more trust into the network. That if you're not going to just give generic markings, you're going to need to have user opt-in, application opt-in, and network opt-in, and have some form of trust that proves that this is not being done without the permission of everyone involved. Next slide, please. And of course, there are many, many privacy implications. If you are blindly putting application information onto the network, there are many statements that IETF has already made around saying that your network protocols should not be exposing information unnecessarily to the network, particularly when it's privacy sensitive. The applications and the patterns of usage that users have is critically important to keep private. Like, that is very much their data and can be abused and misused in many, many ways. So we need to be very serious about that. And it's good to note here that your identity can be exposed even if you aren't explicitly saying, I'm using this network. If we, sorry, I'm using this application, because if there's a policy that the client learns about to say that, oh yes, this provisioning domain, this network slice, this path is only meant to be used by the Netflix app, and you see packets on that, for sure that that user is using that application. So it's not quite good enough to do that either. And again, we kind of realize that the mitigations that were obvious here are either saying we need to generalize the information we're giving to make it more like a traffic class or a category, or we need to have more trust and consent all the way through the path. Next slide, please. We talk a little bit in the draft about suggestions for how you define categories to generalize traffic. Traditionally, we already have markings like DHCP bits, and that can essentially just give different buckets of traffic class. It is possible to say that we could have more specific categories for categories of different types of applications. We could say maybe this is a interactive game as opposed to an interactive video call, and there could be a discussion around where the line is for that being okay from a neutrality and privacy standpoint to share. But we believe that that is where the discussion needs to happen. And then we also make a note that, and this is particularly important for the client OSs, when we're talking about architectures that could give information to the network, we need to make sure that we have bounds on the types of APIs that the internet and transport layer are offering up around how you signal this information. We don't want to see a world in which applications identifiers are automatically scooped up by an OS and being marked on behalf of applications without their intent. We need to have some sort of very explicit opt-in and a way that if we are going to go down the road of having more trust between the network and the application and the user, we need to bootstrap that trust by allowing applications to select or indicate what type of treatment they allow for their network traffic. This could tie into how applications are aware of different provisioning domains, but that's an area that could be explored more. Next slide, please. So that's a summary of the document. It's pretty short. I think it's something that we would like to plant as a seed and see how we can expand upon it and get more input from people. We believe that there is a need in this conversation for a document about principles and requirements so that we can point to something when we're having discussions within the IETF, as well as in other SDOs. If we as a community think that the internet layer should be used in a certain way, let's explain that. So I'd like to hear from people if there's interest in exploring this problem here, and if we think that Intarea is an appropriate place for this. We thought so given some of the previous work we'd done here, but if there's a better venue, we'd love to hear that as well. Thank you so much.
Thanks, Tommy. So Dave?
Two other presentations this week on this topic, but they're in the solution space. And so since you're talking about the problems and considerations, that's why I think this is the best of those three talks. The other ones were in dispatch, which is app area. And another one was in the security area in SOG, okay? And so this gets to your question about what's the appropriate place, because I think the apps area is very much interested in this topic. The security area is very much interested in this topic, and the internet area is very much interested in this topic. I think the style of stuff that you're talking about in this draft right now is most appropriate for the internet area. And so I might think that internet area is the best place for it, meaning I agree with you on that one. But it's going to want review and input from both apps and security, given that they discussed it even this week, right?
Yes.
So that's my main comment on that one. So yes, I'm absolutely interested in it. And I know this is a draft 0-0. I would be happy to help with this one. If you want additional help with this one, I see you got authors from the other two OS vendors. If you want somebody from Microsoft, I'd be happy to help contribute. So
Thanks for the offer. Yeah, we'd love to have help.
Thank you. Spencer?
Tommy, thank you a lot for this talk. I would say definitely yes, interested in doing a document on this, and I'm personally interested in exploration here. The one question I would ask you is whether you think this is engineering or research, and I'm not asking you whether people are doing engineering now. I know the answer to that. I'm asking whether you think it's really engineering or research. Discussions we've had in the PAN-RG research group over the past several years have really talked about in-host trusting network nodes and network nodes trusting hosts as two of the really intractable problems that people have been trying to deal with. PAN-RG isn't where the expertise is on that, but we know a lot of places of things are blown up. So I would encourage you strongly to do it someplace. I would be interested in helping if that's helpful. And but like I said, I would like for people to be really crisp on whether this is ready for engineering yet, or whether it's really research.
Yeah, thank you for bringing that up. Just you can say that just to respond. I personally think that there are actually three different legs of what we can say in this area. I think we should say all of them. And I think there's a leg of this that probably belongs in IAB. That's an architectural statement about how these things all work together. I think there is a leg that is research still, which is the solution space. How do we actually build trust between all of these nodes? Absolutely still research. What we're trying to do here, and I'd love to help to make sure we do it better, is to have an engineering scope statement about what we are doing today, to not to go into the possible solution space of the future, but to say, these are the tools we have. These are the ways that we think it is bad to use the tools, because there are conversations that are going on actively in, how do we deal with 5G slices and stuff that are engineering decisions today in how we expose APIs to applications to deal with slicing, that we need to make decisions about at an engineering level, very soon. So I think there is an aspect of it, but we need to limit ourselves, and that defines the scope of this document, I believe.
I think, and if that turned into anything like a gap analysis for additional tools that we would need, I think that would be absolutely fabulous. And I would hope a future ISG would be excited about doing a BOF on that. Enjoy your day.
Perhaps an IAB document or an architectural document can point out some of the gaps in where the IETF needs to do more work.
Excellent. Thank you.
Thanks. So we're stopping the queue now. So if you are brief, this is an interesting topic, so I want to give a chance to everyone. So please be mindful of time and try to be to the point. Shuping.
So here, I would like to thank you and for your suggestions on the APN, especially you referred to it. And you gave us some suggestions on how to mitigate the privacy issue. And you know that the privacy has been we could say is the top challenges that people has been asked on APN work. And so your suggestion is to categorize the traffic and making them as a group. But actually it has been like this, and we didn't explicitly express that in the draft. And so thank you for your draft, and we have further refined our proposal. And but our focus is more on the network layer, and so we would like to provide the network services within the operator's control network domain. So I will present it later, and we would like to have your review and comments. Thank you.
Thank you. And just to clarify, I think some of the conversation around APN and other things has spurred on the need for a statement here, but we do not view this as specifically a critique on that, but actually a critique of the overall space and trying to have a piece of work that can be used by APN documents, by other documents, as something to point to and build upon principles to use.
Yeah, sure.
Thanks. Miria?
Yeah, hi. So I do agree very much to the point that we should not add any additional personal identifiers to any of the protocols. That's really important. And you add some privacy discussion to it. But I'm not fully agreeing actually to the rest of the recommendation given in this document, which is basically, as I understand it, use application identifiers instead. Gary made my point on the chat already a little bit, and I think like whatever information you signal is very specific to what you want to achieve in the network, and it has to be tailored exactly to that point. So there's not like one set of information that you would just like broadcast in the network and then you hope something nice is happening. I think this is a per mechanism case basis to figure out what is the right information, what's the minimal set of information to not reveal anything that you don't want to reveal, but also to make sure that you get exactly out of it what you want to get, right? Because the risk if you're providing like more information than needed is that the network actually does something with it that you didn't expect. So these are all good points, which I don't think is like exactly what you're saying in the document. And especially there has been a lot of research work about trying to use application identifiers and make somehow use of them. And it's really hard because applications are not really classifiable. There's like every day a new application and they have all slightly different requirements. So I'm not sure like there might be a document we can write. I'm not sure if it's this document, and I'm not sure where it belongs because I'm not sure what should be in there.
Okay, I think I would appreciate then, you know, we could have review, or the specific recommendations can certainly be changed and evolve to be kind of what this group and what the community wants. But I think this is a place where we can start iterating on that from, and you can point out, you know, what are the things that are can be refined in the recommendations.
So I'm a little bit worried that maybe it's a good statement to say what you should not do. Maybe that's important as well, but it will be much harder to actually give a recommendation about what you should be doing.
Yeah.
Great. Thanks. Warren.
Thanks. While I'm asking my question, can we go back to slide 5? So Dave might have already said this in the chat, but I think something that would be really important is to first understand what bits we can't currently do. I mean, a lot of this feels like DSCP or quality of service is stuff that we invented a long time back and was never deployed. Seems like doing the same thing again might not end well. Or maybe this just ends up being, you should use provisioning domains and quality of service done. My concern with this slide is the last bullet of maybe mitigated if users are aware of special treatment. The concern is if the user only has one option, which is yes and yes, making them aware doesn't really help, right? If the user ends up in a situation where they don't actually have a choice, they're just aware that whatever they're doing is subject to this, it doesn't help them at all. And I think that's my soapbox rant.
That's good. That's a very good point.
Michael.
Hi, yeah, thank you. I think the first thing I'd like to see is real discussions on the mailing list. After you posted this to Intarea, I sent a range of thoughts about this. Haven't seen any reply from you or other authors, and neither any other, I think, good discussion. So hopefully we can have the discussion, because certainly I think that topic is very important. And quite frankly, I'm beside the pointers that I was providing in that email of prior work that I did in that respect, and the responses I got back, a couple of years back in Intarea, which would be interesting, I think, to reinvestigate with respect to the, opinions of the organization. A lot of the work where we've seen come from the network equipment vendor industry is not necessarily only the open internet, right? But a lot of these things are a lot more required and requested for by what since 8799 we're calling limit domain networks, right? So and these limited domain networks can go as far as a home network connecting to a service provider where the customer in the home network has an explicit contract. There is all type of, necessarily security, right? We've done protocols like PCP and others for signaling, right? So there is a lot more interaction we can get if we take out the worst possible case of an internet path with transit service providers that have no business relationship and might snoop on the traffic and so on, right? So I think this classification of the deployment models, I think, would be very welcome as a first addition to consider for that, because maybe you're not interested in that, but maybe the example I was just giving raises the interest again, because a limited domain is, I think, 90% of what we're seeing on the internet today.
Thank you.
Shannon?
Hello, Tommy, can you hear me?
Yes.
Okay. I agree very much in the proposal about that in order to mitigate the privacy issue, should not to indicate the individual applications in the to the network. I think that this also has another issue, because we know that the individual applications develop very fast. We depend on the individual application, so that the network has to adapt it to this individual application. This is also very difficult, and also in the practice, we also think that the individual application is very hard for the network to process. Yeah, so that's the first point. The second point, maybe this is also mentioned by the Torres. You know that when do the APN work, we also investigate the scenario, because you know that some this limited domain. You know that for some this enterprise network or their carrier IP network, so the end-to-end controlled by the enterprise or the operators. So that they hope to can identify their applications and that's to find granularity, so that they can easily track to their service. So that's in my point. That is a little different from the internet process. So I want to, because here we want to set up the general principles, but I think not only this is to get the response from the people in the internet, and also maybe also some the limited domain the requirement should also be taken into account. That's maybe helpful. Yeah.
Yeah, that's a good point. And just to respond briefly to the overall limited domain usage, I do think that does fit in well, and I think there is still a need, and there's a gap there that we are trying to highlight by talking about how the applications interact with the network, how they select it. Oftentimes today, a device is not necessarily aware of when it's on a limited domain or open internet, what it should trust or not, and kind of defining those guardrails around what would it be appropriate for an application to do to indicate via an API what it wants to select is something that needs to be done still. All right, I think we've spent a lot of time on this, so we'll see.
Yes, thank you very much. So we definitely have a vivid interest, and then to answer the question, we are going to take it on authors, chairs, and AD to see the right venue and potentially go for an adoption call. But thank you very much for the presentation. So I'm going to put up Pascal's slides, or Pascal, would you like to present yourself?
Well, Juan Carlos, it's easier that you do, but if you want me to, I can.
Okay, give me 1 second. It's a little slow. Okay.
Okay, so we don't have much time. I guess we're a bit late, so I'll skip through quite rapidly. Next slide, please. Okay, so just a quick reminder. No, not this one. First slide first, please. And actually, intriguingly, it's been modified. Can you go back to the previous slide? Okay, so what's this work about? So LP1 working group has defined a new compression mechanism, which is really, really efficient and completely stateful, by the way, to get that level of efficiency. It was defined for LP1 types of networks, so that's LoRa, Sigfox, and BIoT, for instance, types of network. As it goes, this compression could be useful in other domains. And for instance, if you want to use TDM and time slotting in any type of network, and for which you need a fixed size or maximum size, it's very useful to compress protocols. I'm thinking of protocols like Goose, for instance, in electric grid, which is really time sensitive, but at the same time wasting a lot of bandwidth. So it could be cool to use something like SHIC to compress it. So the idea here is to define SHIC over PPP, because if you define something over PPP, then because you have PPPoE, you can use it also over Ethernet and Wi-Fi. So at the end of the day, SHIC over PPP is the way to have SHIC pretty much everywhere. Also, it's kind of classical for PPP to have compression mechanisms, CRFC 5172. So there are already 2 compression mechanisms, sleep and capture capson. So now we are just defining yet another one. So it's not like something completely revolutionary, but it could be dramatically useful. Next slide, please. Okay, so this is basically a packet format of the compression. So for those who have looked at PPP and PPPoE, this is exactly the shape of a PPPoE frame. And starting after the 57, which signals IPv6, you can see the SHIC rule. So that's really the matching table in the stateful compression, and then the compression residue, that is everything that had to be placed online. And if you don't use fragmentation, this draft adds the capability to add some original payload that would not be compressed. For instance, in my example of Goose, you could say, hey, all those long names can be compressed, and then the Goose data itself can be left in line. Next slide. Next slide, Juan Carlos, please. Okay. So status of the draft, very stable, didn't change since last IETF. We discussed it several times at LP1 because there's a lot to do with LP1. But at the end of the day, the LP1 chairs and our AD, Eric, we all decided it's mostly PPP, mostly not SHIC. So that's why it's presented here at Intarea. Next slide, please. Okay, so here is the generic flow that you will see for this draft, but also for PPP OE in general. So what happens, and which is kind of new to the LP1 architecture, is instead of having a sensor device, which is this low-power battery-operated device, and a gateway, which is this service provider side translator, decompressor, etc., we are acting in a peer-to-peer mode where one switch or router is doing the compression and a peer switch or router is doing the decompression. And you've got this PPP session between those two, possibly over Ethernet. So this changes the model because now you don't have a low power side and like a client and server, it's really peer-to-peer. So the cool thing with that is they can actually go and fetch the exact same rule set at the exact same place. This is why after we do the discovery in the LCP configuration, which is like the classical PPP, you have in the IPv6 CP configuration request with option 2, we have this request of, which is the new value. We are saying SHIC as the compression protocol, but we're also giving a URL as the associated data. And that URL is the place where both sides can get the exact same set of rules, which guarantees us to have the right compression decompression. So both sides go and get the rules and get it, and now we can effectively do the compression. So that's the flow, very simple. It really depends, next slide please. It really depends on the SHIC Yang model, which is being defined right now at the LP1 protocol. So where are we? Draft is stable, has been discussed several times at LP1. If there are LP1 consideration, I'm pretty sure we'll do a round after the last call in Intarea. We'll do a round at LP1 to just validate that everything is correct on the LP1 side. But pretty much stable, not very complicated. It's just yet another compression protocol for PPP, which already had 2. So the classical questions, I mean, is there anybody who wants from the Intarea side to help me on the PPP side, just to make sure everything is PPP correct? Do we need more text, or is it already quite complete? Like, do people want an applicability statement, like explain why we need it? Usually we don't do too much of that in a standard track document, but if people think it's necessary, we can write it. And is there anything beyond what is in this draft which could be added? Again, open to suggestion. And also open to the chairs proposing adoption, because now the draft is stable.
Thank you very much, Pascal. So we have time for one question, if there is. Otherwise, I'll ask those people to take it on the list.
Sorry.
Could you hear?
I could not hear you well, Juan Carlos. I'm sorry, the voice went below.
Okay, let me try again. I was saying if we could take one question to make it fast, and otherwise I would encourage people to ask, to answer, Pascal's questions on the list. Okay, thanks, Pascal. I might have some feedback, but I will make sure that I provide it after the meeting. Yeah.
And about adoption, Juan Carlos, are we ready now? Because we didn't move for like six months.
Would you like to? Well,
I'd like to get the sense of the group if it fits there and if we can adapt it. I mean, it's not a work group last call, right? It's an adoption.
Okay. Let me start by asking on the ballot, how many people have read this draft? And I'm starting the poll now. Can you see it in yellow? Yes, okay.
Click on the poll in the upper right to see it.
Right. So I see people starting to vote. So one couple of more seconds. Please raise your hand if you have read it, and do not raise your hand if you have not read it. But the more information we have, the better. Okay, so we have about 6 people that have read it. So please take a look. I think that the intention would be to adopt this draft. and for that we need to have more eyes and more feedback. So as Pascal said, it's quite stable and it's quite simple, but we do need a couple of more eyes to make sure that we're going on the right path. Okay, so thank you, Pascal. So now shipping, you have less time, unfortunately, than previously planned. I'm going to show your slides now. Go ahead.
Okay, hi. Hi, thank you, Chair. And this is Shuping. I'm going to present APN application-aware networking. Next, please. So first, about the purpose of this presentation in here. And we were actually suggested by the IESD and to present in the Intarea area. And we have seen discussions on APN in this working group, and as Tommy just presented. And we also have the APN mailing list, and we have very active discussions there. So we would like to collect more feedback via the discussions here and to further address the concerns raised by the IESD. Thank you. Next slide, please. So basically, I will follow what, why, and how, this logic to organize this presentation. So first, what is APN? APN is about on the network layer, and we would like to enable the implementation of the fine-grained user group, application group, and service level requirements guarantee. And in order to do this, we will focus on developing a framework and a set of mechanisms to derive, convey, and use this we call the APN attribute. And this information will be encapsulated in the data packet, and it will be treated as an object in the network. And to this object, the network operator could apply policies in various nodes or service functions along the path. So what is very important is APN works within a limited operator's domain. And generally, this domain is defined as a service provider's limited domain within this domain. And the operator could apply their technologies and to provide services. And we can see from this simple diagram, and the APN attribute is tagged and removed at the edge of the limited domain. That means once this packet leaves this domain, and the attribute will be removed, and it won't impact the rest of the internet. So next slide, please. So what is equally important is what APN is not. So APN is not about identifying the particular application or the users to the network or within the network. Actually, the network doesn't need to know who you are and what you are doing, which application is actually sending the traffic. And to have this information, it will break the privacy, and we are aware of that. So it's all about policy enforcement in the network. The network doesn't need to know those information, and it only needs the opaque value or a bit string to do the policy enforcement on the various places. I mean, to be specific, is on the network nodes or service functions. So APN is not PAN-RG, and we want to make the network aware of the application's requirements. It's not the other way around. And APN is not Smart Plus, so which carries the information on the transport layer. We use the network layer. And APN is not network tokens, which tags the tokens from the host, but APN takes the attribute at the network edge device. And at the end, it is also the conclusion we derived from the SAT meeting at IETF 108. That is to convey the information at different layers are different technologies, and APN uses the network layer. Next slide, please.
Yeah, we will need to transition to the next presentation in about 4 minutes, so just a heads up.
So now why APN? Here we use a very concrete use case, and it's SD-WAN. And in the case of SD-WAN, the network operators can provide the SLA guaranteed WAN lines to enable the enterprise to access to the clouds. But when we map the WAN line into the network operator's network, and then usually you will find multiple network paths with different SLA guarantees. So in the MEF 70, there are already a list of match items. They are published at the network edge nodes, and which could be used to steer the traffic into the lines. But still, there is the need to communicate the user applications requirements to the network to match to the capabilities of the WAN line. So that is once the traffic goes into the operator's network, there is a need to apply the various policies in the different nodes or service functions along the path. For example, at the head end, we need to steer into the corresponding path to satisfy the SLA. At the midpoint, and we need to collect the performance measurement and also to do the visualization. And at the service function, and we need to execute the policies. So next slide, please. So that is impossible to do it with the current existing mechanisms. Probably we could stack the various policies in a list of TRV in the head of each packet. But you can imagine the big challenges going to be imposed on the hardware processing. And also, when people do the policy-based routing along the network path, normally the ACR via 5 tuples is used, but sometimes it's very complicated to resolve. For example, with the tunnel encapsulation, it's very hard to have these 5 tuples because the transport layer is pushed very down. And with the IPsec, it's impossible to obtain the transport layer. And also with IPv6 data plane, with those in extension headers and to be added, and the transport layer is pushed very further down. It's impossible to get them. Next slide, please.
Yeah, 2 more minutes.
Okay. So how? And here we recommend to acquire or construct this attribute at the network edge and encapsulate it in the packet, and to treat it as an object and then provide services to it. And so that will bring a lot of benefits. For example, now you only need to check one field in the IP layer instead of resolve the 5 tuples in different places in the packet header. And also, it will enable very flexible policy enforcement. And further, so for the SFC, when we do the service function policy enforcement, now you only need to check this one field. It will also enable fine granularity performance measurement and visualization. And it's not only for the overlay, but underlay, but also works for the overlay. Next, please. And here we have done some gap analysis and quickly go through. DSCP is not big enough, and flow label and entropy is for the ECMP, and service ID is only carried in the NSH, but APN, the attribute is decoupled from data plane. IOM flow ID has the dedicated purpose, and the banding seed is bound to the SR, and flow spec label is bound to the MPRs, but APN is decoupled from the data plane. So you can see all the existing solutions are specific to a particular scenario, our data plane. It's not the same as APN, and it's unable to achieve the same impacts. So generally, APN aims to define a generalized attribute used for the service provisioning, and that could be carried in the various data plane. Next slide, please. So I will leave it here, and we have presented in the dispatch and the art. And here are some frequently asked questions. So here I won't go into details, and you can check it from the slides. So, but basically, people have been frequently asked the similar questions. Next, please. Here are some questions we would like to discuss with you further about the security issues, and whether when we do it in the limited network domain, whether there are still security issues, and about privacy. I think we find some ways to mitigate them, and we use opaque value. And so what is most important is the network. When we do the policy enforcement, we don't need to know what the traffic, so who the user is and what application is. The network only needs to know the bit string and to do the policy enforcement. So, next,
we're out of time now, so I'm sorry for the people on the queue, but I think to be fair for the last presenter, maybe we can take the questions on the list if you don't mind.
Okay.
Thank you very much.
Actually, my comment was just, this is the second virtual IETF in a row where you only allocate an hour for Intarea. Could we please, could we get a little bit more overall for these discussions? That would be very helpful.
Thank you very much. We'll take that into account definitely. Yeah.
Hey, hello everyone. Thanks for the time. Today's topic is about the challenges, scenarios, and progress in the internet addressing. Next, please. Next, please. Thanks. This topic is about internet addressing. Internet addressing is all about the IP address. So we know IP address is a carrier for the forwarder to know how to routing a packet. And on the other hand, we know there's a lot of limited domain networks, and they are behind the internet. For this limited domain networks, the requirements, node behaviors, especially for how nodes forward a packet, and the semantics are totally different from the internet address. So if we want to use internet protocol in this limited domain networks, we have to develop some of the additional adaptation technology to make that happen. Next, please. So in this draft, we want to focus on the question in the middle. That is, should limited domains purely rely on IP address and therefore deal with the complexity of translating any semantics mismatch themselves? Or should flexibility for supporting those limited domains be a key focus for involved internet addressing? And generally, this is asked for a discussion on the emerging needs for involving internet addressing and the current objectives and paradigms, especially for the addressing for IPv6. And we are not gonna to propose or promote a solution for these problems. Next, please. What we have done in this draft is that we first provide some of the scenarios. In these scenarios, we found if we're using IP internet protocol in these scenarios, we found some challenges and problems. In order to still make the internet protocol cover this scenario limited domain networks, we have to develop some protocols like 6LoWPAN, and there are new adaptation technologies must be developed to include the internet protocol to cover this limited domain. And because these solutions are within the paradigm of the internet addressing, especially for IPv6, we figure that there are issues and problems we are facing if we're still using solutions within the current paradigm of the internet addressing. So we summarize a lot of issues for using these solutions, and this is what we done in the first draft. We plan to do in the updated version or in the separate document is that we want to find if we want to still involve the internet addressing, what's the challenges we have, and what's the gap we have if we want to do that. So this leads to the two directions. The first direction is that we confirm there are a lot of problems or issues if we insist the current addressing paradigms, and so the issues will stay here, and we are still facing this issue if we insist the current internet addressing. This is the first direction. The second direction is that we think these problems need to be solved, and we need to have more discussion about how we involve the internet addressing. So this is a draft call for a broader discussion for this direction. Next, please.
Yeah, so we're at the end of the hour, so if you can be quick and wrap up, it would be appreciated.
Okay, I think the next slide is for the end of the topic. So the question for here is that we want to talk about if there's really a need for emerging needs for if we want to involve the internet addressing that is beyond especially beyond the IPv6 internet addressing. And we are open to people who would like to contribute to push this work forward. And I'd like to end it up here and open for questions. Thanks.
Thank you very much. So we can take one question. Otherwise, we encourage people to get on the list. Okay. All right. So let's take the discussion then to the list. Thanks everyone for your participation, and we look forward to seeing you online soon in the future. So take care, be safe. Ciao.